Is question 12 of the 3D Trig worksheet, which many of you struggled with. There are some good examples of work. So just Daisy had a good attempt here, and there's also a really nice attempt which was successful from Wanyu as well. So just note they're working out here, but I'm going to go through it in a bit more detail. So when you first look at this question, there's a topic you need to just recap before you cover it. So I'm just going to recap similar shapes. So if you remember when you did similar shapes, if you have a triangle inside another, you can say that they're similar, and you can basically treat this as two separate triangles where one is a scale factor of the other. So what we're going to do here is sketch out both triangles side by side and then figure out the missing length. So in this case, we're looking for length x. So we know that this small triangle is 5 and 4. This large triangle is 20. So we can see the scale factor is 4, and then the scale factor is 4. So that's going to be 16. And we're going to use the same idea with this question here. So let's read it carefully. So AD is 6. So in this case, we actually need to label everything because it's not given to us. So it's going to be 6 centimeters. And then AB is 9 centimeters. CD is 2 centimeters. So that's the height. I'm going to label it on the side because it's going to be the same as GH. And DH is 4 centimeters. Work out the angle between the line that passes through the point BG. So there's a line that passes through BG, and the infinite plane that includes ADHE. So in other words, just if that were to just be extended in all directions, like the floor, if you can think of it as the floor of this this shape here. So that line is going to extend down, and we need to figure out this angle here. So you can see now that I've shown you the similar shapes that actually we have a triangle here, and then we have another triangle here. So what can we work out from this? Well, let's sketch these out. We've got the big triangle, and we've got the smaller triangle. So I know that the height of the small triangle is 2. I know that the height of the big triangle is 9. So I've got I can work out my scale factor. If we're going from small to big, I'm going to multiply by 9 over 2, or 4.5. And we need to work out the length of the base of this big triangle here. So we can do that by looking carefully at this diagram. We can see that if that line there goes through AH, well, then the triangle I can make here is ADH, and that's a right angle triangle. And then the hypotenuse of that triangle is going to be the length of the small part, the first part of this triangle here. So let's work that out. We can say that this is looking at triangle ADH, that's 6, that's 4, that's meant to be a right angle here. So 6 squared plus 4 squared equals AH squared. So AH is equal to the square root of 36 plus 16. And then you are going to get two root 13. Or in this case, I'm going to unsimplify it. I'm just going to leave it as root 52. just for the sake of the fact that it's easier to write. Now I have this length here as root 52. I don't know what this length is here, but I do know that it matches the base length of the small triangle. So we can just call this x. We can call this x. So I know that when I multiply x by 4.5 or 9 over 2, that's from the scale factor from before, I end up with root 52 plus x. So now we just have a simple number rearranging to do here. So you can say 4.5 times x, or in other words 4.5x, is equal to, we don't really need the brackets, but I just want to make a point that they're together, it's root 52 plus x. Now I can just rearrange this and then work out what x is. So 4.5x, and now I'm going to take away x from both sides. Take away x equals root 52. And then I can say 3.5x equals root 52. So x is equal to root 52 over 3.5. On your calculator, you should get, so let's put this in here, root 52 divided by 3.5, I get 4 root 13 over 7. So we have now found this length x here. And then we can use this small pink triangle to work out the angle, because that's what we're interested in here. So we can say that this length here is 4 root 13 over 7. I'm just making this small triangle a bit bigger here for you. So, and then that length is 2. And now we just need to find theta. And that represents this angle that we want here. So we can say that we have the opposite, we have the adjacent, we don't need the hypotenuse. So tan theta equals opposite, which is 2, over adjacent, which is 4 root 13 over 7. So theta equals tan inverse of this. So on your calculator, let's do it step by step. We're going to do fraction 2 over, and then this can be another fraction underneath. So it's 4 root 13 divided by 7. And then you are going to do tan inverse. You get 44. In this case, I think it doesn't ask you to round it. So 44.1 depending on, 0.1 depending on what it asks you to round it to. And that's how you can work out the angle here. If you want to tidy this up without all the explanations, again, I'm just going to zoom in on Wanyu's working out. I'll attach this picture here because I think it's quite neatly shown here. But it's difficult to make sense of this if you don't know what's happening. Okay, I hope that's useful.